Now, the whole idea behind algebra is that if I have an alphabet, okay, these elements, and I apply operations, then I can get a structure, but not always, under some condition. What is this condition? This condition is called the condition of closure of the operation. Note that the notion of closure pertains to the operation, not to the elements. So it's not a closed system. Okay? I'm sure you have heard about the distinctions in this system type of language about closed systems, open systems. This is not the case for what I'm talking about. The closure pertains to the operation. What it means that, let's say, if I have two numbers and I use a scaffolding over which I can locate these numbers, then the addition, let's say, of these numbers will make me land in the same scaffolding. I will not be out of it. Okay, this is the meaning of closure. A nice metaphor to think of, okay, because it's a non-systemic notion, the notion of closure. Think in terms of a body, okay, or a human body, and think about the circulation of, let's say, the circulation of blood. Okay. In order to be alive, this circulation has to have the property of closure. Okay? Okay? It's not about a closed system, it's about the closure of an operation. The closure of an operation gives structure to this scaffolding. That's the idea. So this property of closure now can be applied, for example, to addition or to multiplication. These are the most typical cases, okay, when we talk, for example, about natural numbers. So immediately we have something more now. So we have a spectrum, but this spectrum, in terms of the operation we apply to it, it gains some structure. Okay? This is what gives meaning to the notion of structure. Nothing else. So it's not, structure is not a property of the scaffolding. It's about what you can do, okay, with the elements. Okay, so it has this kind of structure, is all about the closure with respect to some operation, okay, that you apply to a scaffolding which is given by an alphabet. Now let's try to figure out what are these elements. Because, okay, in the natural numbers, you know what the natural number is. But we want to be able to play the same game, not only with natural numbers, but about abstract numbers. What is an abstract number? Variable. Okay? So the whole, the first was the notion of structure. The second big idea of algebra is the notion of a variable. Of course, the notion of a variable cannot be seen independently, okay, from a domain of numbers. This is the road which will lead to the decoding bridge in the diagram, which is this idea of an equation. But let's call provisionally an abstract number, we do not know what it is, a variable. Since we do not know what it is, okay, it's not an object. How can we name it? We need an act of naming, of giving a name. Okay, the act of naming is the symbol. So we need the notion of a symbol, okay, as a placeholder for something that we do not know yet. So algebra works with symbols. And the symbol now is a naming which can run over some domain. Okay? So a symbol eventually will take a form, okay, a morph, which will be a number. But this can be done only if we complete the circulation. And the completion of the circulation requires, as I said already, to be able to formulate equations. Now, let's try to make the grammar of the thing. Okay, so we need a morphology. What we need, we have the numbers, we have the variables, and we have the operations. We need a way to name the operation. How do we name an operation? This is the notion of a sign. Okay? A lot of people are confusing symbols with signs. They're very different things. So you see that, for example, when you make, everybody knows how to write an equation. You use the signs. The signs you use are for the operations. The plus sign, the multiplication sign, and all the different signs, the equality sign, all these different types of signs. So signs and symbols are different things. But what we can do is we can fuse them. What it means, this fusing? It means that I can take the sign of an operation, apply it to the symbol, and make a tensed symbol, okay, which I can consider, okay, as a sign again, but it is tensed. Okay, it's an abuse of language, but because algebra is language, okay, these abuses of languages is exactly what make up language. So we have symbols, signs, we fuse them. For example, if I call plus 5 and minus 5, this is a fusing of a sign with a symbol. This gives me a tension. This gives me a tensed symbol. Okay. So with this, I make a grammar. The rules of the grammar now require something more. What is the more? Let's go to the downside of this diagram, to the down level, level 2. Is this notion of what is called the identity of the structure. Okay. So how is it possible, okay, having defined the structure in this way through operations, using sign and symbols to have a notion of an identity? Okay. This is a critical point. I mean, all the beautiful working of algebra is based on this very, very simple idea, but extremely powerful, of a neutral element. The neutral element you can think of as the cipher. So it is, the whole structure is enciphered in the neutral element. Very simple. Let's start with examples. If you have an operation, addition, okay, what is the neutral element? Everybody knows it's the 0. But what is the 0 doing that we call it a neutral element? The idea of a neutral element is that if you apply it to any element of your structure, it leaves things invariant. So the neutral element okay, incorporates the criterion of invariance of the structure. And out of this criterion of invariance, we are able to talk about the identity of the algebraic structure. Contemplate on how this works, things become quite simple, okay, because this is what the abstraction gives. Okay, eventually it gives simplicity. Okay, but this simplicity comes out from being able to figure that what makes the whole thing work, okay, is first of all the notion of a structure, and the invariance, secondly, the invariance which is given by the neutral element. So the whole game with algebra somehow boils down to figuring out what is a neutral element. And as a result, you cannot have structuralism, any type of structuralism, without neutral elements. The whole identity criteria of structuralism are based on neutral elements. They are not based on properties of the scaffolding. I mean, the usual twist, or in my view, it's a misinterpretation, is to consider the scaffolding as a foundation, and to consider that on this foundation you have elements which bear properties. And out of these properties, now you can define the notion of identity. Okay, this is, you can encounter this type of argumentation very often. But this leads to the failure of structuralism. The only way that structure gains some potency is if you combine it as a bridge with the notion of an equation. Okay, so structure and equation, okay, they come together. And the equation now, what it means an equation, you have two sides, you have an inside and you have an outside. Always. That's the setting. And you have this equal sign, which is the criterion of equivalence. Okay? You say that the first side, which contains something which is unknown and variable, okay, equals what? The neutral element, because I'm able to move everything back and forth. So the criterion of equivalence works always with a neutral element. If you see how the whole thing somehow unfolds, I mean, starting from descending, basically from myths, going to rhetorics, and then to algorithms. When you have developed these categorical aspects of algebra, you need to be able to invert what you have forgotten in the descent. So in the descent, going from myths to rhetorics, you have forgotten something. What you have forgotten are the motifs. So every myth, okay, a good myth is based always on some motif, okay, which will become, for example, let's say a moral value or something. Okay, but every good myth bears a motif with it. Now, descending from myths to rhetorics, you forget the motifs. So the good rhetorician is not revealing the motif. Okay? So from the mythological to the rhetorical, you forget the motif. From the rhetorical to the symbolical, you forget the topos. Okay, you forget the place. Okay, because of the symbolical, you are not interested in the space in the space, in the place which is opened up by your arguments. You are interested only on making chains, okay, programmatic chains of symbols. So to make algorithms. In other words, you forget the topology of the whole morphology by passing from the rhetorical to the symbolical. Okay, these are all acts of forgetting. Now, the interesting thing is that if you want somehow to resolve better, okay, in a more deep level, okay, so you, for example, you have developed computational algorithms, and now you want to develop artificial intelligence, let's say. You figure out that you have to start ascending, so you have to start inverting, reinstating what you forgot. So in order to do artificial intelligence now, let's say with big data and machine learning, you cannot do it only with symbols. Okay, so you need, again, this notion of stochasticity and the topic that you forgot. So the places, the stochasticity, and how different clusters can be glued together. So you need, again, to reinstate the topological aspect that you forgot. And at the further stage, at least in my view, this will be the how artificial intelligence will proceed. So by escaping back the ladder of forgetfulness. So we already have it in mathematics. So in the most abstract categorical mathematics, now the problem is that we already have a way to think of the topos. Okay, it's called topos theory and sieves. Okay, it's about what is a game of rhetorics again. But the next stage is to reinstate motifs. In order to be able to talk about motifs, induction is not enough. Okay, because a motif cannot be induced by anything. So the idea of a motif now is that a motif, the only way that can be unveiled is through abduction. Okay, abduction is like, I can say, the most characteristic case, just to think about. I'm not going now to talk about it. Why we call and we base the idea of Europe, of the abduction of Europa? Have you thought about this? Why the whole idea of Europe, of unified Europe, is based on the motif of abduction of Europa?